good evening. It's your boy Mr. Malachi, and I thought in this video I could take you through these exam type questions on analytical geometry. So this paper comes from the 2023 Gauteng paper. It's a paper 2. It's a final paper that they wrote in 2023. So let's just go through the questions and let's see if we can answer them correctly. So 3.1 wants us, so we're given a triangle there, R is not given, M, P, and Q are given. We see that there's a right angle there. We see that RM is the same distance as MQ. So what does that mean? It means the M is in the middle of R and Q. It's the midpoint of R and Q. So that's what's given in the picture. The first question we're asked to calculate the gradient of MQ. So the gradient, I usually just indicate it with a small letter M. The gradient of MQ is equal to the y2 minus y1 over x2 minus x1. So where's my M? There's my M. I'm going to call this number 1. Where's my Q? There's my Q. I'm going to call this number 2. Why? Because when I substitute, I need to substitute correctly. So the y of 2 will be this negative 2 that is subtracting the 0 divided by the 4 that is subtracting a minus 2. So please make sure when you plug this in, or rather when you're substituting correctly. And if you do this, it'll be a negative 2 at the top divided by a 6, and this is just a negative a third. So that's 3.1. 3.2. 3.2, we are then asked to calculate the equation of MP. MP is this line here that makes a 90-degree angle there. And by the way, if you're wondering what is that line called, that line is called the perpendicular bisector. The fact that it cuts this guy into 2 equal pieces and it makes a 90-degree angle, it's called the perpendicular bisector. So yeah, that was just a side note. How do I calculate the equation of a line? I need, first of all, the M, and this M here is gradient. So I need the gradient of PM. And again, it's calculated using the same formula, y2 minus y1 over x2 minus x1. So I'm going to call the M number 1, I'm going to call this number 2. So if I substitute, the y of 2 is the 6, that is subtracting a 0, divided by the 0 that is subtracting a minus 2. So that's how it looks. I end up with a 6 over a positive 2, and this is just easily a 3. And for interest's sake, I didn't actually need to calculate that. What do I mean? I mean, I could have calculated it in a different way. I could have used my knowledge of saying, ooh, I see that those lines are perpendicular to each other. So I'm going to use this formula here that says M1 times M2 will give me negative 1. If I times those two gradients of perpendicular lines, I will get negative 1. And since I already have M1, which is this negative a third that I already calculated, I could have found M2 using that, and I would have just divided by negative a third on both sides, and I would have ended up with a positive 3 then. So that's another way you could have went about solving for the M, but this is perfectly fine as well. All right, so now that we have the M, we just need the C value. Let's see, can't we figure out the C value from the graph? Oh yeah, the C value is given on the graph. There's it there. The fact that it cuts at 6, that means C is equal to 6. And so therefore my equation is a 3x plus a 6. This is the equation of MP. So we're done with that. Let's go to 3.3. 3.3 then asks us to calculate the coordinates of R. Where is R? R is this end point. We're given the midpoint of it, which is M. We're given the start point, which is the Q. And so I'm going to use my midpoint formula. But the way I use my midpoint formula, I'm actually thinking, let me erase this side and use that as a space to do all my calculations. But I'm probably going to need all these values that I'm just erasing right now. But it's fine. Hopefully we're going to remember them. Alright, so as I was saying, 3.3 wants us to calculate the coordinates of R. So what we're going to do is we're going to use the midpoint formula. Midpoint, which is in this case the x of the M and the y of the M, is equal to x2 plus x1 divided by 2, y2 plus y1 divided by 2. So that's how you calculate the x coordinate of the midpoint using this formula here. So instead I'm going to extract it and say x of midpoint is equal to x2 plus x1 divided by 2. I'm going to extract the second one. The y of M is equal to y of 2 plus y1 divided by 2. And what am I trying to get from those formulas? R. R is an x and a y. I'm going to call that number 1. The Q is my number 2. So wherever I see number 1, I'm going to substitute the R, the x and the y. Wherever I see number 2, I'm going to substitute the Q, the 4 and the negative 1. And wherever I see M, the x of M, I'm going to substitute this midpoint here, which is the negative 2 and 0. So how does that look? For the x, negative 2 is equal to the 2, the 4, plus the x divided by 2. And I just need to quickly solve for x there. Just times by 2 on both sides. You always times by 2 because of this 2 there. So these 2's are going to cancel and you're left with the negative 4 is equal to 4 plus x. And so if you take the 4 to the other side, x is equal to negative 8. Y, a negative 4 minus a 4 is a negative 8. So we got our x value. Now we need to do the same thing here for y. So again, what am I doing? I'm substituting the y of the M, which is the 0, is equal to the y of the 2, which is the negative 2, plus the y of the R. And that's the guy I'm trying to solve for. Again, you just times by 2 on both sides. And if you do that, 0 times 2 is just 0. So you're left with something that looks like that because of these 2's cancels. Then if you take the 2 to the other side, the negative 2 becomes a positive. And so those are your values. And so therefore, R is a negative 8 with a positive 2. Maybe let me put it up here. Just so if I needed some other place, I can use it. Negative 8 with a positive 2. Alright, so we're done with this question here. Let's move on to the next one. So the next one is 3.4, and for that one we ask for the length of PQ. For the length of PQ, I'm going to need the distance formula. And the distance formula is the root of x2, that's x2 minus x1 squared y2 minus y1 squared. And then again, it's a mission of just labeling your guys. Which one is your 1? Which one is your 2? I'm going to call this number 1. I'm going to call this number 2. And make sure when you label, you are substituting consistently. So my x of the 2 is the 4. That is subtracting the 0 squared. The y of the 2 is the negative 2 there. That is subtracting the 6 squared. And if I plug this into my calculator, let's see what I get. Alright, I get a final distance of 4√5 units. And since they said they wanted in simplest third form, we're going to give them in simplest third form, and that is our final answer. So 3.4 is done. Am I going to need that? I don't think so. Let's move on. (3.5) then asks us, given that RPQT is a parallelogram, determine the coordinates of T if T was in the third quadrant. So they're saying somewhere here there is a T, so much so that if this connects there and if this connects there, the total shape is a parallelogram. I know it doesn't look like that, but imagine it is. So how do we solve for T? First of all, what you need to know about a parallelogram is that these diagonals, maybe let me put my T at a very better place that looks more believable. I think T would be somewhere here. One thing you need to know, right, about a parallelogram is that the diagonals bisect each other. So what does that mean? It means this diagonal that is going across like that, the red one, is being bisected by the other diagonal that is going across like that. And similarly, the one that I just highlighted, the red one, also bisects this diagonal. So what is the implication of all of that? It actually means that the M here will therefore be the midpoint of P and T. I hope you're hearing that. It will therefore mean that the M there is therefore the midpoint of P and T, just as the M is the midpoint of R and Q. So how do we find for the T? We therefore going to use the same logic of us calculating for the R. We're going to say T, we're looking for the XM and the YM. And for each of those, I'm going to just put out these formulas like this. X of 2 plus X of 1 divided by 2, YM, Y of 2 plus Y of 1 divided by 2. I like separating it like this so that you solve very easily. So let's call this number 1. Let's call the T number 2. And so remember, T is an X and a Y right now. We don't have those coordinates. We're supposed to solve for those coordinates. Alright, but we have M. So we can already substitute -2 there. If you erase, you should still be able to see that that X coordinate is a -2. The X of 2 is the one I'm looking for. The X of 1 is 0. This is being divided by 2. Again, you times by 2 on both sides. You'll get a -4 is equal to an X. And that's the X coordinate of the T. Then let's do the Y. The Y of the midpoint is the 0 is equal to the Y of 2, the one I'm looking for, plus the 6 divided by 2. And again, you're timesing by 2 on both sides. Why are we timesing by 2? To get rid of this denominator of 2. So 2 times 0 is just going to be a 0. And so what does it mean for y? Y is equal to negative 6. So therefore, t is actually a negative 4 and a negative 6. And there we go. All right. Then the last question, 3.6. Explain why RPQT. So RPQT, we were told initially here that it's a parallelogram, but now they're saying state why it is also a rhombus. Excuse me. Remember, a rhombus is a type of a parallelogram. So there are 3 types of parallelograms. There's a rhombus, there's a square, and there's a rectangle, and obviously there's a normal parallelogram. So all those shapes are types of parallelograms. So what is specific about a rhombus? A rhombus would have this 90-degree there at the center where the diagonals bisect each other. So the fact that the diagonals are bisecting each other is one reason, but the most important one is the fact that it has a 90-degree there. So because PQ or RQ is perpendicular to PT. Yeah, that's what makes it a rhombus, the fact that it's perpendicular there. And a rhombus is a square also does that, but yeah, rhombus is one of those shapes that make a 90-degree angle there where the diagonals bisect each other. All right, so I think I'm done with this question, but what I wanted to add that I thought was going to be interesting is if we had to calculate the area of this triangle. So imagine if a question was asking us to calculate the area of this triangle. So one thing I notice about the triangle is the height of the triangle is the PM distance, and I don't have that distance. I don't think I calculated that distance. We calculated PQ at some point, but we didn't calculate for the PM. So let's calculate the distance of PM, because that's the height of the triangle. And why do I need the height? Because to calculate area, we need half the base and we need the height. So once we're done with PM, we need to also calculate RQ, which is our base of the triangle. So let's calculate PM. PM, again, distance formula, x2 minus x1 squared, y2 minus y1 squared. I'm going to call this number 1, I'm going to call this number 2. Guys, what I'm doing is not trivial. It helps me remember which one is 2 and which one is 1, because the biggest mistake that happens in analytical is the substitution. People just keep substituting incorrectly. They know what they're doing, they're just not substituting correctly. So you don't want to fall in that trap, guys. All right, so that's how the substitution is going to look. Let's plug it in, let's see what we get. And there we go, we get 2 root 10 units. Then again, let's calculate RQ. And I think at some point we had the coordinates of R. There's it up there. So RQ, the distance of RQ, the distance formula again. And I'm going to call this 1. I'm going to call the Q2. So it's a 4 that is subtracting a minus 8 squared. And it's going to be a minus 2 that is subtracting. I think that was a positive 2, né? Yeah, it was a positive 2 that is subtracting a 2. And let's plug that in and let's see what we get. We get 4 root 10 units. All right, so now that we have our base and now that we have our height, we can just easily calculate area. And so area is equal to half the base times height, half the base, which is 4 root 10, the height, which is 2 root 10, and let me just use my brain. This and that will give me a 10, this and that will give me a 2, 2 times that will give me a 4, so this should be a 40 units squared. Let me just double check that with my calculator. 0.5 times 4 root 10. That is times 2 root 10. Yes, you do get 40. And yeah, that's it from my side, guys. I hope you saw how we can calculate gradient, how we can calculate midpoint, how we can calculate the end values when given the midpoint, and how we can find all these things. I hope this helps you for your upcoming tests and exams. And on that note, bye.